Okay, we're here to talk about rule number 9, which is referred to as at least 1. So in this rule, the idea here is that the probability of at least, actually, let me go to the line below. My handwriting is too big. The probability of at least one success, we want to view it as at least one and think of how that relates to something that we understand in real life. So what does at least one really mean? At least one means one or more. So the only thing that we're leaving out if we think of one or more is 0 successes or having no successes at all. So the at least one rule treats this like a complement. So we take 1 and we subtract the probability that there will be no successes. And the way I like to view this, just so that we have it in another form or fashion, is that the way I remember this is at least 1 equals 1 minus none. That's my little trick to my brain to be able to remember this rule and think about it in the proper way. Okay, so I want to do this example below, and then I have another example on the next slide. So let's see if we can think about how to use rule number 9, or at least 1, when we are flipping a bunch of coins, okay? So this says list the sample space. When we flip 2 fair coins, okay, so let's get that. 2 fair coins back to back. So we did this on the very first page of the packet. One possible outcome for 1 coin, we used the idea of it would be heads or tails, and we used the letters H or T. So you can either look at the first page of the student packet, or we can think about the sample space in terms of flipping 2 at a time. So if we flip 2 coins at a time, then maybe one of the options that we look at would be tails, tails. Another option we might see is heads, heads. And then we see maybe heads, tails, and tails, heads. So that completes our sample space, 4 possible options in the sample space. And then it tells us what is the probability. So this language is expecting us to have an answer that's either a fraction or a decimal. And then it says that we flip 2 heads. Okay, so I'm going to use the probability notation and say that we flip 2 heads. So that looks like HH. And that's the number of HH's over the number in S. And S stands for the sample space. So for us, our sample space has 4 things, and one of them is heads, heads. Okay, so let's do part C, and we're going to see how we could use the at least 1 rule to think about part C. So it's asking what is the probability, and it says at least 1 tail. Okay, so first of all, that's the key language that we're looking for. At least 1 is the language from our rule, and then tail is the success in this case. So I'm going to replace the rule using our version of success. So let's jump under here. So instead of saying at least 1 success, I'm going to say at least 1 tail, because that's our version of success. We want to know what's that equal to. So that would be 1 minus, if we look at our formula, the probability we have no successes. And in this case, that's tails. So at least 1 equals 1 minus none means that at least 1 tail would equal 1 minus no tails. So these are complements of one another. I either have 1 or more, or I have 0. And that's why we're allowed to subtract from 1. So I actually know the probability. I have no tails. No tails is equivalent to HH, right? Heads, heads. That's the only way to have no tails. So based on part B, we know that this would be 1 minus 1 over 4. And if we do that math, we get 3 over 4, or a probability of 0.75. Okay, so the next question I want to do is actually from the same exact page in the student packet. It's from page 5, and it's right below. What I'm going to do is go to the next page so we can see a new example, and we're still going to use at least one. I'll rewrite the rule on the next slide too. Okay, this one says a box has 30 spools of ribbon. So this is the same as problem on page 4, but it's going to ask us new questions. It says 12 are pink, 7 are green, 6 are white, 5 are gold. Okay, so we have 12 that are pink. I'm actually just going to use the first letter. I guess GR for green and GO for gold. 7 that are green, 6 that are white, and 5 that are gold. Okay, you reach into the box, you select one, record its color, put it back, and select a second spool. This is called with replacement. Okay, so these are, if it's with replacement, these probabilities are independent. When I replace the item into the sample space, they're effectively not changing the sample space at all. Okay, so both times I reach into this box, I will have all 30 spools of ribbon. All right, now let's read what they're asking us to do. Find the probability. Okay, so we know the answer is a decimal or a fraction. Selecting at least one pink spool when choosing 2 spools. Okay, so they're telling me right away, when choosing 2 spools, this is telling me that I'm going to have 2 fractions, right? 1 for each spool. Okay, that's all that part means. We want to focus on this language, at least 1. So in our problem right now, success is pink. So I'm going to rewrite the problem for us. At least 1 pink. Okay, so at least 1 was 1 minus no successes. So for us, that would look like 1 minus the probability that there are no pink spools. Okay, remember, we're choosing 2 at a time. So this really looks like this. 1 minus, and then we're going to have 2 fractions multiplied together. So I'm going to set it up like this. And this is with replacement. So the first fraction will be over 30, and the second fraction will be over 30. Now what I want to think about is how many of those spools are actually pink. We want them to be not pink. Remember, no pink is the same. If we think about our notation from complements, that would be like pink with a line over it, right? That would equal not pink. Okay, so my question to you is, I'm going to jump up here. If 12 are pink, how many are not pink? Okay, we need to think about that. So there's 2 ways to think about it. We can either do 30 minus 12, right? So 30 minus 12 is equal to 18. The other way we can do it is we can take the green plus the white plus the gold, and we would also get 18 if we add all that together. So we now know that we have 18 spools that are not pink. So that would be our numerator. I want it to be not pink and then not pink again. That means no pink spools were chosen. So I want to do this subtraction, and if I do that, I would get, I only have this as a as a fraction. Hold on one second. Okay, so this is equal to, if I put that in my calculator, I would got 0.64, okay? So we want to try that again for the second example, okay? So this is at least 1 equals 1 minus none. So we did at least 1 pink is 1 minus no pinks at all. So let's try this again for part B. What is it asking us to do now? Find the probability of, so again, find the probability of selecting at least 1 pink spool. We're still choosing 2, but this time without replacement. Okay, so these are without replacement, automatically makes this not independent. My denominator shrinks. Okay, so every time I reach into the box, my denominator will decrease. So let's read this together. This says the probability of at least 1. So we're going to set it up the exact same way. At least 1 pink. That's equal to 1 minus the probability we have no pink. So again, we're going to set this up the same way. 1 minus, and we're going to have 2 fractions. This time, the first one is over 30, and the second one is over 29. This is because this is without replacement. So again, these are both not pink. So I reach in the first time, and there are 18 that are not pink. I take one of those and I keep it. So now there are 17 left that are not pink. If I put all that in my calculator all at once, I'll get the answer. I'm going to do 4 decimal places like Alex loves. 0.6483 if I round it to 4 decimal places. So this is my example of at least 1. Let me know if you have any questions at all.